The way to do that for somebody that's starting out is to either use the set screw and use it as sort of a locator spot, or if you're starting out with this stuff, just take it, go from the center of the tip here somehow, and just kind of put it off to the side, right? As a sort of as a reference. So then when you fire it up, I don't know if everybody can see this one, but you can see that one centerpiece, and what we're looking at is the center. Right there, it's pretty much stopped, okay? But now, so that's the fundamental speed of it, which this thing is running slow, 993 RPM. Now if I double that speed, I'd end up with two of them, okay? But it's flashing twice per revolution. So you see the centerpiece here I'm talking about? Alright, if I go up to about 4,000 RPM, you'll now see that there's about four of them. Well, there's only one, but it's your persistence of vision it's allowing you to see that. It also allows you to see the overlapping of each wing. And there's multiple things here. There's either the clock, which means they're this wing relative to this wing. If it's spaced right, you can see the edge here, or you can see the tip here. These aren't too bad, but you can maybe see a little difference between them as it comes around. The other thing is like the spider. You can see how it's shaking pretty bad. You can see the rivet heads. So the rivet heads is a good thing to locate and kind of look at to see that they're moving in and out. So that shows that the spider is bent. And one of the reasons on the Vortex blade is this is all thin aluminum. It's the same thickness as the blade. It's just all been stamped out, formed out of one sheet. And so they're real easy to get out of alignment this way if you get a curtain caught in them, or a broomstick drops in them, or
a cattail.
You throw a cat at it, and it throws them out. But the Vortex or GEs, and hell, that's good enough.
I guess it is.
Yeah.
Now, when you put those cabbage roses on your fans, does that throw the balance off?
I farmed that work out to Steve Sherwood. So
no, you don't.
what the thing of it is, you can, when I take a look at a blade, first of all, I'll try to just kind of get an idea of where it looks like it's worse from the others, where the gap or the separation is different from the others. Can you guys all see what we're talking about on this? On the edges of them, can you see the multiple edges?
It's flopping all over.
Well, it's flopping all over, but you can also. But what I'm talking about is it looks like there's like three blades or so overlapping each other, and you can see the back of it that the spider is also on. So that's one of the worst ones. There's been people have different concepts of what they think is the best way to mark these. I started out first of all with like a liquid paper and just putting some dots on them, and like putting 2 or 3 dots on each, numbering them with dots. And then I ended up using the tape, white tape, and people have suggested, wire marker tapes and stuff like that, but it seems like just regular vinyl tape works best for me, because it's got the adhesive, but I can also pull it back off. Some of the wire markers are usually pretty gummy, so then it's best to start out from the center of the blade, or the spider, and work out. Get the clock and bend them around so you get this first, so they're in clock, before you start messing around with the pitch and this kind of stuff. So just try to keep in mind to work from the center out if you can. Get the clock first and then worry about the ends. Okay? Here's another one over here. Flip that one on. And I put some big numbers on that so you can... Yeah, somebody wanted to sell that to me, but I think it's just on loan. It doesn't have a knob on it.
It does. Bottom, you just put.
Well, the other things about this is real nice too is with it, like if you've got a digital stroboscope, you can tell what the RPM is, and if you have like a meter, the amount of power, and you get an idea of whether it's pushing air or not. If there's not enough blade pitch in the fan, if it doesn't push enough air, the RPMs go up. And if you put more of a blade pitch to it, that's going to be more of a load on the motor, and the motor goes back into an area where it's really designed for. Every manufacturer designs motors for certain load RPMs. And typically 4-pole is somewhere in the neighborhood of 1,500. I used to talk with Jim Lindsay about all this stuff, and about 1,550 RPM is a good point to use to determine how fast how much